사이신 경야는 최고사령관 김정은 동지께서 주체의 선군혁명력을 진루에서 이끄시기에 우리 혁명무력은 영원히 백성만을 떨쳐나갈 것입니다.
In the beginning of 2016, North Korea announced that it developed a hydrogen bomb, sparking international response.
Korea's leader Kim Jong-un claims the reclusive state has developed a hydrogen bomb, a step up from the less powerful atomic bomb.
News into the CNN newsroom. A magnitude 5.1 seismic event has been detected in North Korea. The U.S. Geological Survey says it was recorded in the northeastern part of the country near the site of a 2013 underground nuclear test.
North Korea's claim it tested a hydrogen bomb brought swift condemnation from around the world.
To begin looking into whether North Korea has a hydrogen bomb, we need to first understand what the hydrogen bomb is, how it works, and what makes it so powerful. A common misconception is that the hydrogen bomb is a nuclear weapon. It is actually a form of thermonuclear weapon, which is very different than nuclear. Nuclear bombs rely on fission and are equivalent to around 15,000 tons of TNT. Thermonuclear, on the other hand, rely on both fission and fusion and are as powerful as 50 million tons of TNT. More importantly, they've never been used in war. To put that into perspective, here's what the blast radius would be if the atomic bomb dropped in Hiroshima were dropped in Lower Manhattan. Here's what would happen if you dropped a hydrogen bomb instead. Now, let's look at why the bomb is so powerful and how it works. We'll break the explanation up into 3 stages. The hydrogen bomb is composed of 2 parts, the primary and the secondary. The primary contains fission fuel and involves the processes found in the atomic bomb. The secondary, on the other hand, contains a combination of plutonium, uranium, and lithium deuteride, which ultimately allow for a fusion reaction, the main source of the bomb's power. Lithium deuteride is used instead of pure hydrogen gas because it is easier to control. In stage 1, the uranium in the primary part undergoes fission by a triggered explosion. Next, the X-rays and daughter particles from the primary explosion heat up the casing of the second, causing immense pressure. This pressure induces fission in the plutonium rod, which superheats the lithium deuteride. Neutrons from the fission combine with the lithium to form fusible tritium and deuterium. Under the immense pressure and temperature, the tritium and deuterium undergo fusion, which results in massive amounts of energy. Lastly, the neutrons produced from the fusion reaction collide with the uranium casing, causing even more fission. Thus, the bomb has 4 sources of energy, 3 from fission reactions and 1 from fusion. It is important to note, however, that the fusion reaction is what gives the bomb its destructive power.
To begin looking into whether or not North Korea actually has the hydrogen bomb, we spoke to Professor Lind of Dartmouth College.
So people are really interested in the question of whether or not North Korea has reached this ability to have a hydrogen bomb, which is that this would obviously give it a far greater destructive capacity relative to the other kinds of weapons that it's been detonating so far. So basically from the last test that we saw, in the aftermath, North Korea claimed it had a hydrogen bomb, but experts immediately questioned whether or not this was actually the case. And subsequent study of the test and the different indicators that we're looking at basically have led some to conclude that they may have what is known as a boosted fission device, that it's not a hydrogen bomb, but they are indeed making progress in their nuclear capabilities just to achieve that.
The boosted fission device Professor Lind mentioned uses hydrogen isotopes to increase the bomb's yield. This development has worried global officials that a hydrogen bomb is possible in the near future.
Is building a hydrogen bomb economically feasible for North Korea? To take a look, let's start with their economy. North Korea's entire economy is about $28 billion. To put that in comparison, New Hampshire, our state's economy, is about double the size at $57 billion. What's worse, North Korea spends about 47% of its GDP on industry. That includes other services. But even if they spent all of that on military, it would be about $13 billion. To make matters worse, North Korea's economy isn't exactly growing. They have about 1% GDP growth per year, which is negligible. Their infrastructure is falling apart. They only have major trade with China and Russia, and they have no private investment.
Let's put this in perspective by assuming that North Korea is starting from scratch, as the U.S. did during the Manhattan Project. The U.S. economy during the time of the Manhattan Project was about $2 trillion, and the Manhattan Project cost $23 billion, about 1.2% of U.S. GDP. North Korea only has a GDP of $28 billion. Even if they spent half of their GDP on producing the bomb, this would only be $14 billion, much less than the cost of the Manhattan Project. Adding to the cost of the Manhattan Project, you would need deuterium and tritium for the fusion reaction in a hydrogen bomb, neither of which occur naturally and both of which are extremely expensive to produce. Now let's talk about uranium. In naturally occurring uranium samples, the 235 isotope is about 0.117% of the sample. However, to get uranium to be enriched to weapons grade, you need it to be over 85% of the sample. Once uranium is mined, you can use gaseous diffusion, showed here, or gas centrifuge, in order to enrich the uranium. North Korea probably uses gaseous diffusion, the less efficient method, since they don't have very good capital goods in their country. A uranium enriching facility can cost $5 billion a year. Not to mention that since North Korea uses no nuclear power, they probably don't have very many. Adding tritium and deuterium costs to this seems to make a hydrogen bomb economically infeasible for.
While a hydrogen bomb is not possible in the immediate future, North Korea is nonetheless advancing, becoming a threat to international authorities.
What we're seeing, though, is that with this new test, is that North Korea is indeed making progress. So their capabilities are improving. And so this is worrisome because this is they're showing that they're further along the line to a place where they could credibly threaten U.S. bases in East Asia, or even if it gets the delivery systems down to a greater capability than it has in the past, they could even threaten the U.S. homeland.
Even though North Korea has faced international pressure concerning their nuclear development program, they have shown no signs of slowing down. In the past, nuclear weapons and mutually assured destruction have ironically held together the cracks in the international community. But if North Korea were to obtain a hydrogen bomb, it's highly possible that its aggressive and irrational leader, Kim Jong-un, could compromise global security and redefine the world we live in. Looking ahead, the future is far from certain, but what is known is that the landscape of international politics and security could very well lie in the completion of one nation's scientific achievement.